So for this one, we're going to start with our basic format of y equals a times b to the x. And I got two different coordinates. So I know that when y is 29.495, I know that x is 20. And I also know that when y is 730.89, I know that x is 150. So now we have two equations. Now we can kind of substitute and solve for these two values. So if I divide both sides by b to the 20th power, I know that a equals 29.495 over b to the 20th power. Now I can take this and I can substitute this in for a in the second equation. So you see I plugged everything in, and then I have b to the 20th on the bottom, b to the 150th on the top. And the nice thing is it's basically division. So when you have division, you're essentially just subtracting those exponents. So it's 150 minus 120, which is b to the 130th. And then we got that 29.495 in front. So now to solve for b, we're going to divide both sides by 29.495. And then we get b to the 130th equals this, which I'll evaluate in Desmos. So now I get approximately 24.78. And last but not least, we're going to take the 130th root, which is the same as taking this to the 1 over 130th power. So again, taking this in Desmos, I'm just going to go like this, and I'm going to say to the 1 over 138 power, and we get approximately 1.025. So if I know that's b, now I can take this and I can solve for a. So I can plug it into either equation. Let's plug it into this one here. So we're running a little low on room, but we have 29.495 equals a times 1.025 to the 20th. Now to solve for a, I'm going to divide both sides by 1.025 to the 20th. So this is will cancel out. We'll do this in Desmos. And we get 17.99999, but we're going to round it up to 18. So that means a is 18. So now coming back to our original, if we want to write it out, we'd say y equals 18 times b, which is 1.025 to the x power, and done.